So, because vectors have both magnitude and direction, and because vectors are really points on a plane, we can't add or subtract vectors in the same way that we add or subtract scalar values. So in this lecture, we're going to look at how to add and subtract our vectors. So let's begin by looking at the addition of vectors. Now note that whenever you add vectors or whenever you subtract vectors, you will get a vector as your result. Now, let's begin with the addition or algebraic addition of vectors. Note that there are two ways to add vectors. We can add them algebraically or we can add them graphically. So let's begin with the algebraic method. So let's look at vector v1 and vector v2. So this vector is represented algebraically as the coordinate point 3, 3. And likewise, this guy is represented algebraically as the coordinate point 2, minus 2. So another way to represent these vectors is by using matrix notation, which simply means you put two brackets and you put the x-coordinate on top and the y-coordinate on bottom. Likewise, the x-coordinate goes on top and the y-coordinate goes on the bottom. Now these guys are simply two different ways of representing the same vector. They mean the same exact thing. Now, suppose I want to add these guys up algebraically. So, vector v1 plus vector v2 equals, I simply take my two coordinates and replace these guys. And I get 3, 3 plus 2, minus 2. So, my next step in adding these guys up is I first add up my x-coordinates and then I add up my y-coordinates. So, 3 plus 2 as my new x-coordinate, 3 minus 2 as my new y-coordinate. Because 3 plus 2 and 3 plus minus 2 is simply 3 minus 2. So I get my new vector that I got by adding these guys up is 5, 2. And let's say this is vector v3. So let's represent this vector graphically on our xy plane. So we begin at the origin and we end at the point 5, 1. So I go 5 units on the x-axis and 1 unit on the y-axis, and I draw from the origin to this point and I finish off with an arrowhead. So this is my vector that I get after I add up v1 and v2. So notice it's somewhere in between. It's pointing somewhere in between these two vectors, and that makes sense. Because if this guy's pointing somewhere this way and this guy's pointing somewhere this way, their addition is the vector pointing somewhere in between. So note that I can add these guys up in the same way that I added these guys up. So 3 plus 2 minus 2, two matrices, I combine them into a single matrices and I simply add up my x-coordinates and my y-coordinates. So 3 plus 2 and 3 minus 2 gives me a matrix or a vector 5, 1. And that's the same exact vector that I got here. So these two guys are the same vector. Now, suppose I wanted to add these vectors up graphically. How would I do them? How would I add them graphically? Well, first, recall that whenever I draw an arrow, it has a head. So this is my head, and this is my tail of my vector, right? So, tails begin at the origin, and the heads end somewhere else. So if I wanted to add these guys up graphically, this is how I would do it. I begin with any vector. Say I begin with my vector v1, and I draw my vector v1. And then I take my second vector, I take the tail of the second vector, this part, and I put it on the head of my first vector. So I take this guy and transfer him here. So this is exactly what I get. My first vector and my second vector. And my vector that I should get after I add these guys up is simply, it starts at the origin, it starts at the place, at the tail of my first vector, and it ends at the head of my second vector. So, begins at the tail of my red vector v1 and ends at the head of my second vector v2. So this and this guy is exactly the same. So, I found this guy algebraically, and I found this guy graphically. And these two guys give us the same exact result. These two methods give us the same exact result. Note that if I first took this vector and then I added this vector, I'll get the same exact result. In other words, if I first start with this guy and then I take this guy and put the tail of it on the head of this guy, I would still get the same exact vector pointing in the same exact direction, and that vector will have the same exact magnitude. So that's how you add them. Whenever you add two vectors, you should get a vector as a result, and you can add them two ways, graphically and algebraically. So now let's examine how we subtract our vectors. Remember, whenever we subtract two vectors, we will get a vector as our result. Now, there are two ways to subtract vectors: algebraically and graphically. Let's look at the algebraic method first. Suppose we have the following two vectors, v1 and v2. And let's say our v1 is the point 2, 4, and our vector v2 is the point -2, -3. Now, the matrix representation of these vectors is 2, 4, and -2, -3. So let's suppose we want to subtract vector v2 from vector v1. So we want to find v1 minus v2. So first we take our point and plug it into this vector, and take this point and plug it into this vector, and we get this result. Now, notice that instead of adding our x and y coordinates, now we're subtracting them. So 2 minus -2 will give us the new x coordinate, and 4 minus -3 will give us the new y coordinate. So our new x coordinate is 4, and our new y coordinate is 7. So the vector that we get when we subtract vector v2 from vector v1 is vector 4, 7, which is vector v3. So let's graph this guy, and we get the following resultant vector, result. Now note that if we subtract these two matrices, we would get the same exact thing. So matrix 2, 4 minus matrix -2, -3 will give us matrix 2 plus 2 for the x coordinate and matrix 4 plus 3 for the y coordinate. And our result will be 4, 7. The same exact result as this. So since these guys agree, these steps are the same exact steps, except we're using different representations. So this is how you subtract vectors using the algebraic method. So now let's look at the graphic method. In the first step, we choose any vector and draw the vector with the tail starting at our 0, 0 point, at the origin. So let's choose our blue vector, our vector v1. So we start by starting at the origin. The tail begins at the origin and it goes to the point 2, 4. Second step, take the second vector and add the head of the second vector onto the head of the first vector. So we take this vector and we bring it up and we add the two heads. So head goes on head, and this is what we get. And now we connect the two tails. So you go from the origin, which is the tail of our first vector, the blue vector, and go to the tail of the second vector, our red vector. And we see that this result gives us the same exact result as in when we subtracted using the algebraic method. So these two give us the same result, the same direction, the same magnitude, but the first method is the algebraic method and the second method is our graphic method.